Hi Algebra 2, this is Unit 6, Lesson 11, and today we're going to talk about the locus definition of a parabola. Alright, so we have some new terms to go over. My parabola is in blue right there. Vertex is something you're already familiar with. The vertex is the turning point. But new terms, let's actually look at the definition of a parabola. The definition of a parabola is a collection of all points from a fixed point and a fixed line. All right, so the fixed point is going to be called the focus, and that's in green on your picture right there. So my focus is right here, so that green point. And the directrix is a line outside the parabola. So the focus is a fixed point inside the parabola. The directrix is that red line right there. It's a line outside the parabola. The vertex is the turning point. It's halfway between the focus and the directrix. And P is the distance from the focus to the directrix. All right, so every single point on this parabola, let me just get a blue pen, every single point, so this point right here is the same distance from the focus as it is to the directrix. See how I'm marking those congruent? This point right here is the same distance from the focus as it is the directrix. So every single point, the vertex is also in between, equidistant between the focus and the directrix. So every single point on that parabola is equidistant from a fixed point, which is the focus, and a fixed line, which is the directrix. Every point, even the point up here, is going to be equidistant from the focus and the directrix. It's the same distance away. Every point. That's the definition of a parabola. All right, so the equation of a parabola, we're already familiar with this part right here, x minus h squared plus k. The h and the k are giving me my vertex, but this point right here, the 1 over 4p, is new to us. If 1 over 4p is greater than 0, the parabola opens up. Well, that makes sense because it's positive. We're used to that. If 1 over 4p is less than 0, the parabola opens down. We already know my vertex is my HK, and I add P to get the focus, and I subtract P to get the directrix. To find out how wide the parabola is, we add 2P to the focus each way. And this is something that we're going to work on a little bit today, but more so tomorrow. All right, so let's look at a problem to see what's going on. Graph the parabola y equals 1 over 8, parentheses x minus 5 squared plus 2. All right, so this right here gives me my vertex. So my vertex is 5, 2. All right, so I'm going to plot that 5, 2. There's my vertex. All right, so remember my equation from up here. In front of those parentheses, in front of the x minus h squared is 1 over 4p. So basically, I'm going to take that 1 over 4p and I'm going to set it equal to this to find out what p is. Because I add p to get the focus and I subtract p to get the directrix, to get that point in that line. All right, so I'm going to say 1 over 8 equals 1 over 4p. I'm going to cross multiply, and I'm going to have 4p equals 8, so p equals 2. First question, is it open up or down? Well, that was positive, so it opens up. I have my vertex. I now know p equals 2. So my focus is going to be 2 away. So this right here at 5, 4 is my focus. My directrix is going to be 2 this way. So that's going to be this line right here. Going to be 2 away. So this is the line. So my directrix is y equals 0. How wide is this going to be? Well, remember, to find out how wide the parabola is, you add 2p to the focus each way. I add 2p to the focus. I should have made my focus maybe a different color. This is my focus right here. So my focus is in red, and it's 5, 4. So how wide is it? I add 2p to the parabola to find the how wide it is each way. So I'm going to add 2p, 2 times p, 2 times 2, which is 4. So basically, I'm going to go 4 here, 1, 2, 3, 4, and I'm going to go 4 there, 1, 2, 3, 4. And this is my parabola. I'm just graphing it. So you're able to graph it without using a graphing calculator. All right, pretty cool. All right, let's turn this over. Let's try another one. Graph the parabola y equals negative 1/6 x plus 1 squared minus 4. All right, well, this opens down, and I know that because that's negative in front. All right, so I'm going to take 1 over 4p, and I'm going to set it equal to negative 1/6, because I'm trying to find out what p is. Cross multiply, and I have negative 4p equals 6. Divide by negative 4. Oops, p is going to be a fraction. P is negative 3/2. My vertex comes from here. But remember, I got to change the sign for the h, so my vertex is going to be negative 1, negative 4. So I'll start by plotting that point, negative 1, 1, 2, 3, 4. Okay. My focus is going to be, it's p away, so it's basically negative 1.5 away. Again, I'll do that in red. Okay, so my focus is going to be negative 1. The x stays the same, but I am doing negative 1.5. So negative 4 plus negative 1.5 is negative 5.5. So it's going to be down here. It's in between. All right. How wide is it going to be? So to find out how wide it is, I go 2 times p. So 2 times negative 3/2. So basically it is negative 3. So I'm going to do negative 3, 1, 2, 3, and negative 3, 1, 2, 3. And that will give me my parabola. I know it opens downwards. And this one, oh, it did ask me for my, what? Oh, no, I wrote the focus in the wrong spot, didn't I? All right, sorry about that, guys. So the focus right here is negative 1, comma, negative 5.5. And then I skip directrix. So the directrix is 1.5 away also, so it's going to be right here. Right smack in the middle. It's going to be y equals negative 2.5. Okay? All right. Write the equation of a parabola with a focus of 1, 4 and a directrix of y equals negative 2. Use the graph to find p. All right, because I have to know p. So I have a focus of 1, 4. I'm going to graph that. There's my focus right here. I have a directrix of y equals negative 2, so that's right here. Now remember, my vertex is right smack in the middle. The vertex is halfway between the focus and the directrix. So let's see what that would be. So halfway between them, I've been doing my parabola in blue, so I'm just switching colors. 1, 2, 3, 4, 5, 6. So halfway between them, my vertex should be at 1, 1. So P is the difference between the focus and the vertex. So P is just going to be 3. I'm just measuring this right here is 3. And I can write my equation. So my equation is just going to be 1 over 4 times 3 minus, parentheses, x minus 1 squared plus k. So that's really just going to be y equals 1 over 12 x minus 1 squared plus 1. Done. Kind of cool. All right, I got another one on the next page. Consider a parabola with a focus of 3, 3. All right, so 3, 3 is my parabola. 3, 3 is my focus. A vertex of 3, 1. 3, 1, okay. Find the directrix. Well, the vertex is halfway between them, so my directrix is going to be, if this is 2 away, see how p equals 2? Then my directrix is going to be 2 below at right here, at y equals -1. And write an equation to represent this parabola. So it's going to be, it's opening upwards, so it's going to be 1 over 4p, p is 2, x minus 3 squared plus 1. So it's really just 1/8 x minus 3 squared plus 1. Done. Okay, consider the parabola, last one, that has a focus of 0, 7. All right, so 0, 7 is my focus. Directrix is the line y equals 3. Now remember, my vertex is right smack in between them, so let me change the color. So they're 1, 2, 3, 4 apart, so it's going to be right smack in the middle, right there at 0, 5. Sketch a diagram of the parabola and identify its turning point. So P is 2. How wide is it? And we're going to talk about this some more tomorrow, is 2P. So 2 times 2 is 4. So basically from that focus, I'm going to do 4, 1, 2, 3, 4 to the right, and 1, 2, 3, 4 to the left. And that tells me how wide it is. So then I can sketch it. And write an equation that we've been doing all along. So 1 over 4p, and it's x minus 0 squared, so it's actually just x squared, plus 5. So 1/8 x squared plus 5, because my vertex was 0, 5.